Okay, so we continue with the second part for a method of integration by parts. Okay, we have some examples with solutions that you can refer. All right. Okay, so we have a few questions here for example 2. So we have 5 integration, okay, that need to solve, and there are the types of the functions are different. Okay. Alright, we have A, B, C, D, and E, and I will give you the solution for each question. Okay, so let's begin with A. Okay, for question A, okay, we have ln x as the function. Okay, we need to integrate that function, and if you see, you only have one function which is ln x. Okay, but this question cannot be solved by using directly, okay, by using direct integration, or even using the substitution method. So at this moment, the best way to solve the integration is by using integration by parts. Okay, but for integration by parts, we need to let u and let dv equal to some function, right? So since we have only one function, which is ln x, so actually in front of ln x, you will have 1 here. Okay, so what you will have actually 1 ln x. So we have, if you refer to loped, okay, ln will comes first before the polynomial 1. So that's why we will choose, or we will let u equal to ln x. Okay, and dv is equal to dx. Okay, this is as the ln x, this is ln x, and dv is dx. Okay, so now we have u equal to ln x, so what you need to find is du dx. So differentiate ln x, you will get 1 over x. Okay, and then we have dv equal to dx. So integrate both sides. So integrate dv is equal to integrate dx. So this one, you will get what? V equal to x. Okay. So I didn't put the plus c there because I will only substitute plus c, or I will put plus c at the end of the solution. Okay, so now we have du dx, okay, and we have v. Okay, if you refer to the formula, so the formula is to integrate u dv. Okay, the formula that you need to use is uv minus integration of v du. Okay, so we have we have choose u and we have obtained the v. Okay, now is du. So du is, you can get from the du dx. So from the du dx, you will get du equal to 1 over x dx. Okay, so therefore, okay, ln x dx, okay, you can write as uv minus v du. So we have u as ln x and v is x. Okay, minus integrate v just now is x, and our du is 1 over x dx. Okay, so this one can be cancelled out. Okay, so I will have x ln x minus integrate dx. So this integration, okay, this integration, So we'll get what? X plus C. Okay, so here we have x ln x minus x plus C. Okay, so this is the solution for example 2a. Okay, next we proceed to example 2b. Okay, we have the function of x exponent x. Okay, so x exponent x, so we have by using Lopet just now. Okay, the function x is polynomial and e is exponential, so p and e, so p comes first, so we will let u as the polynomial which is x and dv as exponent x. Okay, so from u equal to x, so you will have du dx equal to 1. Okay, which means that you will have du equal to dx. Okay, and for dv, so integrate dv is equal to integrate exponent x. Sorry, this one you will have exponent x dx. Okay, so integrate 1 dv, you'll get v. Integrate exponent x with respect to x, you'll get exponent x. Okay, again, by using the formula, okay, which is uv minus integrate v du, so you will get u is x, v is exponent x, minus integrate v, which is exponent x, and our du is dx. Okay, so the first part we just rewrite the terms. Okay, but the second part here is the integration. So this is just a basic function, which is integrate exponent x, you will get exponent x, and then don't forget to put plus constant. Alright, so this is the answer for P. Okay, let's move to C. Okay, so C, we have a combination also, polynomial and exponential. So we have Lopet just now. So polynomial and exponential, so we will choose the polynomial as u. But the difference from the function in the example B just now is we have the limit here. Okay, the limit is from 0 to 1, which means that the final answer is not only plus C, but you need to replace the upper and lower limit. Alright, so before we substitute the upper and lower limits, let's solve the integration without the limits. Okay, so we let u equal to x, so we will have du dx equal to 1, and also you will have du equal to dx. Okay, so another one we have dv is equal to exponent negative x dx. So integrate dv is the same as integrate negative x with respect to x. So integrate dv, so we get v. Okay, and integrate exponent negative x, so you will get what? Negative exponent negative x. Okay, so this is the integration, the substitution that we use. Alright, next is to insert to the formula, which we have uv minus v du, which is equal to x, okay, negative exponent negative x minus integrate negative exponent negative x du is dx. Okay, so we will have negative x exponent negative x plus exponent integration of exponent negative x. So solve for the integration, so you will get what? Exponent negative negative x plus c. Okay, so this we have plus c because we just solved the integration. So since we have the definite integral, okay, therefore, so from 0 1 x exponent negative x dx, so we will get negative x exponent negative x minus exponent negative x, and we put the limit from from 0 to 1, which means that you need to substitute x with 1 first, and then minus substitute with 0, so 0 minus exponent 0. So this one we will have negative 2 exponent 1 plus, okay, exponent 0 is not 0, okay, so exponent 0 is 1. Okay, so this is the answer. Okay, 1 minus 2 exponent negative 1. Okay, next. Okay, next is the combination polynomial and trigonometric. Okay, again, if we refer to LOPAT, polynomial and and trigonometric, so polynomial comes first. So we will let u as x. Okay, and from here we will have du dx equal to 1. So du equal to dx. And another one we have dv. Okay, dv is cos x dx. Okay, so from this we integrate both sides. So integrate 1 dv, we will get v. Integrate cos x, we will get sin x. Okay, so this is a basic integration that you need to remember. Okay, but for your midterm or your final exam, the formula will be given. Okay, alright, so this is v. So what you need to do now is to use the formula, which is uv minus integration of v du. Okay, our u is x, v is sin x, minus integrate sin x. So du is dx. Okay, so solve the integration. So we again, here you can integrate directly. Integrate sin x, you will get negative cos. So negative negative, you will get positive cos x plus c. Okay, and since you have the definite integral, which means that you will have okay, so you need to put the limit of the integration from 0 to pi over 2. You need to replace with pi over 2 first for the x value. Okay, so we will have pi over 2 sine pi over 2 plus cos pi over 2 minus, I put in bracket, so x plus cos 0. Okay, sine pi over 2. Okay, since we have sine and cos, I just draw the graph of sine and cos. So this is pi, over here is pi over 2. So sine pi over 2, you will get 1. Okay, but for cos, start from 1. So this is pi, so this is pi over 2. So cos pi over 2 is equal to 0. Okay, and cos 0 is equal to 1. So the final answer will becomes pi over 2 minus 1. Okay, so this is the solution for D. Okay, so let's move to the last question, okay, for integration by parts. Okay, we have now x squared exponent x. Okay, so if you refer to Lopat, okay, we will use the polynomial which is x squared as u. Okay, so let u equal to x squared, so du dx is equal to 2x. Okay, so here we have dv is equal to exponent x dx. So v, okay, integrate exponent x, I will have exponent x there. Okay, but for u here we need to have du, so du is equal to 2x dx. Okay, so now when we substitute into the formula, so we have uv minus integrate v du, so we will have x squared times exponent x minus integrate, our v is exponent x and our du is 2x dx. Okay, so if you look at okay, the first term x squared exponent x is just the same, but if you look at the integration here, so we have another product function, which is we have exponent x 2x. Okay, so again here you cannot use direct integration, or even you cannot use substitution method. So the best way at this moment is by using integration by parts. Okay, alright, so if I use integration by parts, okay, or this one I can, to make it easier, okay, I put negative in front. Okay, so I don't have here, so what I need to do is just to integrate this term. Okay, so integrate this term, so we need to let new u equal to x, so du dx is equal to 1, where we will have du equal to dx, and another one is dv is equal to exponent x dx, so v is equal to exponent x. Okay, so by using the same formula, so we will have uv minus v du as what? X exponent x minus integrate v, which is exponent x, and replace du with dx only. Okay, so now we have the simple integration, which is just integrate exponent x, so you can direct integrate the function. Okay, so actually all this formula or all this solution is for this integration. Okay, so what you need to do next is to get the solution, which is we have x squared exponent x minus 2. Okay, I put in bracket, so x exponent x minus exponent x plus c, or if I open the bracket or I expand, so I will get this answer. Okay, Right. So as a conclusion for this kind of question, okay, x squared exponent x. So since we have x squared here, okay, you need to do 2 times the integration by parts. Okay, this is the first integration by parts, and this one is another integration by parts that you need to solve. Sorry, the first is the first integration, and then this is the second integration by parts that you need to solve. Okay, so actually we will simplify everything in this topic, okay, integration by parts, by using another method, okay, which will be discussed on the next topic. All right, okay, so to them, thank you.